Well, hello, pre-calculus students and seekers of general truths. In this video, we are going to prove a sum of these special fractions in the form of 1 over n times n plus 1. I see here that there's actually a typo. This should be 1 times 2, not 1 times 3. So let me correct that. Okay. Yeah, so that right there should be 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, and so on. Okay. And we are going to complete this proof using induction. So let's look at the base case. This is when n is equal to 1. Right, on the left-hand side, it's just we're using this formula here, 1 over n is equal to 1, so 1 times 1 plus 1. So this gives me 1/2. On the right-hand side, n is equal to 1 over 1. This is our values of n, right? Plus 1. So this is also equal to 1/2. So that's very nice, very straightforward and gentle. Now let's move on to our inductive case. Okay. And we are going to, once again, assume true. And I always like writing out my assumption here. Assume that the formula is true for n equals k, and we want to show that it's true for n equals k plus 1. In other words, that 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus ... all the way up to 1 over k times k plus 1 plus one more, right? Because we want to go all the way up to when n equals k plus 1. So 1 over k plus 1 times k plus 1 plus 1, or k plus 2, is going to be equal to the right-hand side, which is, instead of n here, we're going to have k plus 1. And then in the denominator, we're going to have k plus 1 plus 1, or k plus 2. So we want to show that this sum here on the left side is in fact equal to this neat little formula on the right side. Now again, we get to use our inductive assumption. So all of this right here up to the kth term, when n equals k, is equal to k over k plus 1. Okay. All right, so remember, the original thing that we're using here is that n over n plus 1. Now we're going to add one more term to this, 1 over k plus 1 times k plus 2. Okay, this is our left-hand side that we are working with. So we gotta get stuff to be the same common denominator, so we have to multiply this term here on the left, the part in blue ink here, by k plus 2 over k plus 2. So this is k times k plus 2 over k plus, whoops, this is going to be k plus 1 times k plus 2. Okay. Plus 1 over k plus 1 times k plus 2. All right, let's merge this all together and let's see what we got. So on the numerator, we're going to have k squared plus 2k plus 1. And in the denominator, we're going to have k plus 1 times k plus 2. And the only way we're going to go from this expression to the right-hand side that we're aiming for is just we can actually factor the top factors into k plus 1 times k plus 1, or k plus 1 quantity squared. And you can see these factors cancel out really nicely, and what we are left with is the right-hand side of the formula. And there you have it. The inductive step is true, and the base case is true. So we know that the formula is true for all possible values of n, 1 or greater. when n equals 1 or greater. All right, that was another proof here on how to use, or another example here, how to use PMI. Hopefully you're getting some good practice at this and getting more comfortable and familiar with it. If you're not, ask for help, ask questions. Thank you for watching. Have a wonderful day.